Welcome, and thank you for joining us for today's webinar. My name is Catherine, and I will be serving as your moderator. The presentation today is entitled, Taking Financial Services Operations to the Next Level Using Streaming Analytics. Our presenter is Steve Wilkes, co-founder and CTO of Stream. Steve has served in several technology leadership roles prior to founding Stream, including heading up the Advanced Technology Group at Golden Gate Software and leading Oracle's Cloud Data Integration Strategy. Throughout the event, please feel free to submit your questions in the Q&A panel located on the right-hand side of your screen. With that, it is my pleasure to introduce Steve Wilkes.
Thank you, Catherine, and good morning, everyone. So today we're going to go through majorly how streaming integration and analytics can help financial services with some of the pressures and issues that are being faced today. And those pressures and issues come from a variety of different places. And we'll look at those, and we'll look at how technology can help. We'll look at use cases that show this and do a demo, a live demo of our software for one particular use case, and then talk a little bit about our platform. So you're probably all very aware of all these external factors that the financial services industry has to cope with. And this is from a Gartner CEO study, and they looked at everything and what was the major things that are keeping people up at night. And obviously, a lot of things kind of are outside of your control, things like macroeconomic factors, social political environment, that you can predict what might happen, but you're not always going to get it right. Like people most likely would not have predicted Brexit, for example. But you need to have technology in place and systems in place so that you can move rapidly and change things rapidly if you need to be able to handle those types of changes. And similarly, you have lots of pressures from technology itself, and that can be surfaced through competition and new competition that you might not have expected, you may not see coming, that is a totally new innovation that was happening under the covers, but it wasn't always completely obvious. So all of these things can utilize information, and the faster you can utilize information, the faster you can make decisions, the faster you can make change, and the better you can deal with some of these pressures that are keeping people up at night. If we look particularly at the technology advances, there's so many different areas to focus on. These are some of the key areas that have been identified in CEO and CIO studies. So we have artificial intelligence, machine learning, that is, you have to look at how do you incorporate that to provide investment advice or better customer service. You have IoT and digital twins, and this is interesting to think how this impacts the financial industry. Obviously, you have things like continual monitoring of ATMs and information kiosks and things like that that enable better customer service because you can monitor them, you can predict when they're going to fail, etc. But then you have things like the insurance industry that is looking at monitoring people's driving habits, people's health, people's houses, to predict and catch issues before they become huge claims and try and preempt those claims from happening. And to also tailor policies so that you can have better match to actual individuals rather than broad categories. You have this notion of digital labor or robotic process automation, which is trying to automate a lot of the processes that may have previously required people or humans in the mix, but you're now utilizing some automated system. And so things like automated telephone systems, chatbots, even account entry, and things that would have required people in the mix, mortgage approval, loan approval, risk analysis, those kinds of things. You can start automate that, and that obviously requires some integration with artificial intelligence as well. And then you have blockchain, which is seen as a way of decentralizing things that are currently centralized, and a way of creating an immutable, trusted ledger, trusted record of activity that can incorporate financial information, but can also incorporate other information as well around individuals that it can be managed. So the access to which piece of information can be managed, who sees what, and to help gain control over that kind of information. And all of this requires technology investments in cybersecurity and ensuring that threats are managed and that data is not compromised. So in addition to kind of these new technology innovations, we also have a requirement of modernizing the data infrastructure. And there's these disruptive technologies that require additional technologies, additional capabilities as part of a data infrastructure. But then there's the changing and more complex processes and automation of processes. There's a changing regulatory requirements and analysis and monitoring of those requirements. There's a big demand for great customer experience and user experience when they're interacting with organizations, and being able to understand what your customer's doing ahead of time to give them the best customer service. And then we have these increases coming down the wire of high data volumes, huge velocity of data, not just from data that's currently being generated, but all of the IoT devices that will be incorporated into the mix. And pressures of being able to reduce costs and moving to better cost-efficient infrastructures, e.g. cloud, while still keeping within regulatory requirements. So all these kind of competing pressures are pushing organizations towards modernizing their data infrastructure. So if we start thinking about technology, enterprise cloud, IoT, these things aren't islands. They're all part of a connected ecosystem. And you need to think about the data in all of these and how the data works together, how you can make better value from that data by combining it. And I mentioned earlier, data generation rates and data volumes are growing. This is from an IDC study from a few months ago. And they're forecasting that today we generate around 16 zettabytes of data annually. By 2025, they're estimating that's going to leap to 160 zettabytes, and that's 160 followed by 21 zeros. That's a lot of data. Anyone with a math background will recognize this as an exponential curve, and that means that in every 2-year period, there's more data generated than in the whole history of mankind before that. So in the next 2 years, we'll generate more data than has ever been generated in the whole history of mankind, which is pretty amazing. So by 2025, that'll be 160 zettabytes of data. Now, of that, today around 5% of that data is being generated and needs to be dealt with in real time. By 2025, they're estimating that 25% of all this data will be generated and have to be dealt with in real time. And of that, 95% of it will come from IoT. The really interesting thing here is that all this data is being generated, but if you look at storage and storage growth and storage availability, only a small percentage of this data can ever be stored. There's literally not enough physical hard drives, flash drives, tape storage, any newfangled storage technologies available on the planet to store all of this data. So if you can't store all the data, the only thing you can do with it really is to process it in memory and to turn that data into information before it even hits disk, because you can't store all of it. So you have to work out what you need to store. Now, it's not just IoT data that arrives in streams. It's all data. All data is generated because something happened. You have data in databases that didn't magically appear. It appeared because humans entered it, because some event occurred, because some activity on a website occurred, some deposit or withdrawal, an ATM occurred. Every entry in a database is because something happened. And so it's inherently events, but they're viewed as database tables as a historical record of the past. Similarly with log files, machines write logs. They don't write them a file at a time. They write them line by line. It's just people deal with them as files. And so inherently, if all data is generated as events, we should be streaming that data and processing it as events, not in batches. And the whole batch concept was because memory was expensive, CPU was expensive, storage was cheap. So you just store everything and then process it as you can with the amount of memory and CPU that you have. But that's turned around, and we just saw storage isn't going to keep up with data, but memory and CPUs have gotten much, much, much cheaper. So the capability of doing real-time in-memory processing on data and actually seeing data as it should be as events in data streams is now possible. So all of the data in the enterprise can be streaming. And so stream processing then becomes this major infrastructure requirement. Now, it's not that moving to a streaming first architecture means completely replacing everything you have. Obviously, that is an untenable notion to just repair everything and replace it completely with something new. But moving to a stream first architecture is essential for a lot of different use cases, including streaming analytics, cloud integration, hybrid cloud, integrating IoT, and it can bridge the old and new worlds of data. You can take a database, for example, and use change data capture and turn it into a streaming source of data. And so it's not that you have to knock down that beautiful castle and replace it completely with a glass and steel skyscraper. You can merge the two, and you can have the new technologies working alongside the old ones, and keep those old processes in place, those old applications in place, until, if possible, you can phase them out. So it's certainly possible to use a streaming first architecture with what you have today and have the old and new worlds work together. Now, streaming integration and analytics is quite a new but a simple concept. It means that you are collecting data the instant it occurs. You are processing it and analyzing it in memory. So without it hitting disk, without you storing intermediate steps, you're doing all the processing and analytics in memory, potentially across a large cluster of machines that enables you to scale up and deal with huge volumes of data. And you're also delivering business events as they are identified, as the analytics or the processing determines that something is interesting, something is important. You can deliver that somewhere, and then you can store it. But the majority of the work is done in memory. And then on top of this, you can visualize and understand what's happening, again, in real time, instantaneously, as things are happening, rather than with batch jobs at the end of the day. So the key to this is to be able to run continuous SQL-based queries on data in motion. And that means that instead of running a query against static data in a database and getting a result, you put the query there in memory. As data is generated, it flows through that query and results flow out the other side. And you can chain these things together in a data flow, end up with quite complex processing and detailed processing and multiple different types of processing on the same data for different types of applications. But you're doing that continually. So it's continual in-motion flowing of data through pipelines, through queries, and outputting results, writing them somewhere or visualizing it, sending alerts, etc., and doing that continually, not as jobs, not as batches. Now, operational successes in a large number of different areas within the finance and other industries require these fast insights. So if you think holistically, this is just a number of different areas that you can think of. Things like risk management, regulatory compliance, customer experience, and operational excellence all have use cases that involve real-time analysis. Being able to analyze up-to-the-minute information and make real-time risk-based decisions and get these real-time insights into things is key to risk management. On the regulatory side, being able to continually check, are we meeting regulatory compliance is essential. And on the customer side, knowing what customers need before they do, before customers have to call customer support, proactively dealing with issues so that they don't have to call support. So being able to work with customers proactively rather than reactively and really enhancing their experience to keep them as customers. And then also being able to monitor things. And this could be monitoring your operations, monitoring the expense and resources and globally managing that, but also monitoring security threats and understanding your threat level and impact that security can have on financial institutions. So being able to make these smart decisions based on, for example, machine learning to identify things that you may not see just out of raw data. The streaming integration and intelligence is also important for these technology advances that you mentioned before. If you think about AI and machine learning, it's one thing to be able to train a model and to have that model understand your data. It's a totally other thing to actually operationalize it and turn that machine learning into something that can make decisions based on current events, based on what's happening right now. So streaming integration can really help integrate artificial intelligence into your whole process and operationalize it. Similarly with IoT, you have IoT devices, but the key thing, importance of IoT is the data that's generated. So being able to work with that data in real time, being able to collect it, process it, analyze it at the edge, in the cloud, wherever it makes sense, and do that in a scalable way to handle large amounts of IoT data is kind of crucial to the adoption of IoT. Then you have digital labor, where not only do you have to organize data workflows and automate processes, but you need to be able to monitor this, monitor the responsiveness, and ensure that it is working as it's supposed to be working. And so this creation and automation of the process, and also managing the data required for that process, delivering it in real time to ensure that process happens at the right speed, and also monitoring it also requires real-time integration, streaming integration. And for blockchain, you have blockchain as an immutable ledger, a distributed immutable ledger. But you still need to be able to get data into it. You need to be able to write to it. You also need to be able to correlate it against it and do analysis and aggregation, right? So you can use streaming integration to create the processes that end up writing things into blockchain, but then also to compare and correlate and join real-time information with what is in a chain in order to validate things and automate things. And that can feed into a lot of the other technological advances as well. So these things don't just sit in isolation. They all join together as kind of things that can be used together. And cybersecurity goes across all of this. So the ability to detect and act on security threats that are real threats, not large amounts of alarms going off and false positives, but to really optimize security analysts' use of time to really identify the really key threats is essential part of cybersecurity. And that involves huge amounts of data, as much data as you can get, and probably machine learning to be able to identify threats that you aren't currently looking for based on unusual or anomalous behavior. So those are kind of some of the pressures that are driving change. And if we look at some of the use cases that we are seeing, you'll probably help understand how streaming integration analytics can work within the financial industry. So we'll take a look at risk management and compliance use cases, ranging from fraud detection through cybersecurity. Then we'll look at some customer experience and innovation type use cases, and operational excellence, monitoring, predictive maintenance, how all of that fits into the whole industry and enterprise as a whole. And also IT itself, technology itself, how do you make best use of it, and how do you integrate that and make that part of your processes? And we'll do that after a demo. So let's look at fraud prevention. Now, for fraud prevention, really, you need to act as quickly as possible. Fraud detection is one thing, right? Fraud detection is kind of after the fact, you're doing forensics, you're understanding that a fraud happened after it occurred. But with fraud prevention, you're trying to stop it. You're trying to head it off at the pass to ensure that you never really get to the fraud situation. So you need to continually monitor real-time data, send real-time alerts, and potentially trigger workflows, and even get into the path of a transaction, and provide insight into that through dashboards and visualizations. The benefit, obviously, is that if you can prevent fraud from occurring, then you minimize the fraud-related losses, as opposed to allowing fraud to occur and then dealing with it afterwards. And by incorporating AI into this, you can spot fraud that you may not have been able to spot before. So I'll give you an example from a retail bank that we work with, and they're reducing ATM fraud losses. There's a number of different rules they use. These are just a couple of different rules that they're using. First one is obvious distance measurements, where you're looking at how far people travel between card usage on a single account. And if cards used in two different locations within a time frame that is too far apart to travel, then that will trigger an alert. And it can actually get into the path of that second transaction and require secondary authentication on that. So you prevent that second transaction from occurring unless someone responds to a text message or some other means in order to actually complete that transaction. The second example is where people are checking balances. So they've gotten a whole bunch of cards, and now they are checking to see if the cards work, or if the information they have about the card and the PIN actually works. So they have multiple cards and they're checking them in the ATM. And if they don't then go in and complete a transaction, then it can be that they're just checking to make sure the cards work. And again, that can be something that can cause an alert. You can even alert authorities to go and check that person out. So these are examples that we have with customers where they are monitoring ATMs in real time to understand what's happening and to try and help prevent fraud. Another example is anti-money laundering. This, again, is looking at transactions. You're looking at what transactions are suspicious and could be indicative of money laundering. So here, we're looking at multi-channel data. We're getting information about transactions, trade systems, things that people are doing on the website, ATMs, etc. And that's all being joined together and correlated within the Stream platform to look for particular rules. And we have a number of different customers that are doing this. They can be quite closed, opaque with exactly what all of the rules that they're using are, for obvious reasons. But just a few examples would be looking at people that are doing trading that doesn't make sense or doesn't completely make sense, right? So they're doing too many transactions, too many sales that could indicate money transfer. And if it's the same people doing it, the same people doing the buying of shares, selling of shares, that could indicate money transfer that's going on. So being able to spot that, also being able to spot small bill deposits and large bill withdrawals, unusual activity on multiple accounts. And there are even cases where, and we'll see this in another example, you can start to look at groups of people, collections of people working together in concert to actually create this type of fraud or money laundering. And that requires a different type of technology. So this is that example where an insurance company wants to particularly look at fraud rings. Now, if two people are involved in the same two people are involved in multiple accidents, then you might be able to spot something that's happening immediately. But if the ring is quite big and the number of people involved in it change, but there are relationships between people and vehicles and accidents that create a ring, then that can indicate that fraud is happening, that instead of just two people always agreeing we'll have accidents and defraud the insurance company, you have a ring of people that are doing that. And so the approach that we're using here with the customer is that they've loaded lots of historical claims data into a graph database called Neo4j. And then real-time claims data is continually also fed into that Neo4j graph database. And what the graph database does is it takes people and cars and accidents and who's driving, who was hit, that kind of relationship, and it builds a graph of those relationships. And in certain cases, the graphs of those relationships will form a ring. So you don't just have a chain or sets of clusters of disconnected people. You actually end up with a ring. And the more occurrences that happen within that ring, the stronger that ring is. And so by feeding real-time claims data into this Neo4j graph database, and then in real time asking, is anyone involved in this claim in a ring, you can identify immediately potential fraud scenarios. And so this is something that is working with this European auto insurance company, and it pushes the frauds automatically to a live dashboard and to alerts, and you can save millions of euros by minimizing this type of auto collision fraud. It's something that applies not just to auto insurance, but to also other types of insurance as well. And graph databases are becoming more and more important. The key is how to operationalize that. And again, operationalizing things means that you have to integrate with real-time data, and you have to make it part of your data flows, part of your operations. And that's really where streaming integration and analytics comes into play. Cybersecurity is another broad area with lots and lots of use cases. Here, it's essential to be able to collect, parse, enrich data from lots of different places, from network routers, VPNs, firewalls, multiple devices, sensors, system logs, and to be able to correlate all of that together and look for threats that might span across those different logs, those different devices. So the benefits is that you can get this holistic view of your security across all the different things that you might have been previously monitoring individually. And I identify attacks that go across those things. So if you see a port scan from a particular IP address, and then one of the IP addresses that it hit is then downloading something from a malware site that you see through the firewall, and then that then does its own port scans. You correlate all of that by the IP addresses. You can see that is a much bigger threat than if you just got a single alert, a single port scan. So by being able to correlate all these things together and present the correlated information to security analysts, you're increasing the security analyst productivity. and proactively alerting them to the really true high priority threats as opposed to all these individual little alarms and alerts that are going off. So we have a leading credit card network that is using us for security analytics and a number of different places. One of the key pieces is to collect data from a lot of different sources, correlate it, and then push it out onto a security hub. And they're utilizing Kafka as a security hub. So all of their security data is being pushed out there after it's gone through us as the collection points. We collect it, we correlate it, we enrich it, we also filter it and turn that data into information, so kind of reduce the huge amounts into something that is truly information, and then push that out onto Kafka. And then also using us to read that data again, amongst other applications they have, and build analytics and visualizations on top of that. And then they've also integrated with H2O, which is a machine learning library, and training that with user behavior and running that user behavior model in real time against the current data. So there's a lot of things going on here that range from data collection, preparation, correlation, distribution to a lot of different targets, including Kafka and Hadoop, enrichment of the data with blacklisted and proxy and other information, and alerting, being able to identify security threats that cross multiple logs and alert on them, and allow detailed security analytics as well, like the number of alerts you're getting from all of the devices. Are the devices functioning okay? So there's a lot of stuff going on here in this particular example. Proactive customer service is another use case where you're really trying to understand the customer, to notify customer about things that they may have done incorrectly. Maybe they've lost an ATM card, or maybe you are seeing potential fraud on their account. To tell them that they need new versions of applications, or they've left themselves logged in somewhere, maybe on a public computer, right? So being able to notify them of things like that, and also real-time application monitoring, and where they are in a process, if they've applied for a loan, if they've applied for a mortgage or an insurance policy. Not waiting a week before you tell them, but notify them as you go through different steps of a process, so they know where they are and feel as if they're being included. And automatically escalating VIP customers that you need to be able to treat well, especially well, being able to identify those customers and escalate them. The whole point is to improve the customer experience by knowing at least what the customers know when they do, but ideally more than the customer knows and before the customer knows it. So you can act proactively rather than reactively to customer complaints. So we have a Turkish retail bank that is utilizing us for the call center. And so the bank is offering credit lines and loans, and you kind of plugged onto the side of their existing kind of customer relationship application by doing change data capture against the database, monitoring the process, monitoring how the customer is along with the process, and then being able to send messages to the customer as they move along the process, so that they feel as if they are part of the process, and rather than waiting to the end when they get a phone call saying, yeah, you've been accepted, or you've been declined for this particular loan. So this is all about keeping the customer in the loop and ensuring the customer knows, even if the customer needs more information, the bank needs more information from the customer, being able to let the customer know immediately rather than waiting a day or 2 days before you ask, and then that delays the whole process. Being able to monitor ATMs and do predictive maintenance is also about keeping customers happy. So being able to use IoT and remote device information CPU usage, temperature, all these types of things, but then also things like does it have enough ink, paper, resources, cash, and being able to look at that, not just where is it now, but based on usage patterns, based on what we normally see in this area at this time, what do we predict is going to happen? And based on those predictions, do we need to go and proactively fix things or work with things? So this is, again, applicable to anywhere you have customer interaction with something that can fail, that you need to be able to predict that it can fail, and work proactively to preempt that situation rather than having it occur. Obviously, you get improved customer experience, but you're also driving your own operational savings, because if you're acting proactively, you can schedule things in a organized manner that best makes use of resources. If you're reactive, then you don't have that luxury and it costs more money. And we also have customers doing monitoring of actual financial transactions themselves. And this particular example, and we're going to see the demonstration of this, is where we're monitoring overall transaction volume across a number of different channels, whether it's credit cards, ATM, check cashing, cash withdrawals, etc. And we're looking at the overall transaction volume and how often customers are declined, how often they're told, you can't have that money. Right? Obviously, there are normal types of declines where the customer doesn't have the money to withdraw. But then there are other types of declines where there's a machine failure or a system failure or a financial network failure or some other issue in a location that caused a greater rate of declines. And so by monitoring this in real time and looking at the rate of decline, not just overall, but by multiple dimensions, you can start to see, is there any issues that should be taken care of? And is it related to something we're doing or something one of our partners is doing? And how do we get on top of that? And again, you're really trying to meet the customer experience, to meet your SLAs, and improve your overall efficiency. Because if you're getting transaction fees for every transaction, you want to optimize and get the maximum number of transactions. And if you're not getting that, then you are not making the biggest profit you can be on this. So if we go and take a look at kind of how an application like this is built, we will go into our applications and we'll start this. We'll take a look at this actual data flow in a short time. But first of all, we'll just go into the dashboard for this. So this is a real-time dashboard, and it's showing everything that I mentioned that we would show. You can see transactions flowing through, and these are obviously simulated. I'm not directly connecting to a transactional financial transaction network. But you can see the transactions flowing through. These are the transaction volume. This is the decline rate. This is a decline rate by the type of transaction, so debit, ATM, check, credit card transactions. This is by financial networks. This is by the type of card, etc. So this is a monitoring dashboard, but in addition to that, we're also getting alerts sent out if the decline rate increases by more than 10% in the last 5 minutes. So the data here is a little bit sped up, but it basically means that if we are seeing more declines coming from a particular location or coming from a particular financial network or a particular type of card, then it indicates something. It indicates we should go and look at that in more detail. And obviously you can drill down onto certain aspects of this. It's an interactive dashboard that allows you to see why declines are happening and what's causing the declines, and look at information by state, look at information by all these other things and drill down into them. And this dashboard isn't hard-coded at all. It's actually built using a dashboard designer where you can drag in visualizations from this sidebar into the dashboard and configure each of these visualizations. If we take a look at this one, with a query that talks to the back-end data processing. So behind all of this, there's a data flow that is collecting data, processing it, analyzing it, and then making it available. This dashboard is looking at that available data and is fed in real time from the back end by this query. So that's kind of how you build these dashboards, and you configure things so that it looks the way you want. And if we look at how that was put together at the back end, you'll see the data flow starts with reading transactions, and you're reading data from a data source. In the actual customer example, this is a database that has all of the financial transactions written into it, and we use change data capture to read out from that database. And each one of the steps along here, you're doing some processing. And so the processing in our platform is through SQL-based queries. We can take a look at a query here where we are doing some transformation. We are pulling out different pieces of, say, the terminal ID, which may represent the state code. We're looking at different codes that indicate credit, debit, ATM, check, etc., and different responses, and determining what those responses actually mean. So this is an example of how you're using SQL within here to kind of enrich the data flow, and to so you can see, as the data is flowing through here, we can look at the data. This is the raw data coming in, and then when it reaches this point here, we've changed those codes into the actual responses. And that's kind of how the overall data flows work across the whole application. Some of the processing that happens in here is simple aggregations and looking at stuff. There's more complex data flows that happen looking at the actual decline transactions, where we have queries here that are looking to see whether transactions are declined or not, what the reason for it is, and then utilizing that to build the averages and build those averages by dimension that allow us to react really quickly. So that kind of shows you kind of how you go about building applications using the platform. The applications can be built through this UI. If I kind of stop this application from running and undeploy it, you'll see that there's a whole palette of components that you can drag into this data flow to build these things. So if we drag in new components in here, then we can configure them and set up their properties to connect into our data sources. We also have, if you are building new applications, a whole set of wizards that enable you to kind of start that process off easily, and that allows you to connect into databases, for example, and build data flows that process and deliver that data into something else, maybe into blob storage or into Kafka or into Hadoop, etc. So we have all these kind of helper wizards that kind of take you through that process as well to really simplify how you're building these things. So that's just a quick view of an application running in the Stream platform and what it takes to build it. So it takes the data flow, and it takes, in this case, because it was an analytics application, a visualization as well. If we look at things like IT modernization, streaming integration and analytics can seriously be used for that as well. So it sounds like a simple use case, but in reality, it requires a lot of moving pieces. And that's moving data to the cloud. Moving data to the cloud isn't just a one-off process, right? You need to do it continually in order to ensure the cloud is continually up to date. And that typically requires an initial load of data to the cloud, followed by continually ensuring that it is up to date. And you do that by using, in the case of databases, change data capture. So the process is that you start capturing change on a database, you then initially load that database to the cloud. And that initial load process could be you're doing transfer over a network, but it could also be that you are backing up the database into a small refrigerator and shipping that to the cloud provider where they do the instantiation in the cloud. So it can take time. In the time that that's happening, you don't always have the luxury, or pretty seldom have the luxury, of stopping people using that application. So the database is going to be changing. So that's why you start collecting changes before you do that initial load. And then once the database has been instantiated in the cloud, or the target has been instantiated in the cloud, you can start applying the changes from when you were doing that initial movement. And then keep that going. And that will keep, not only bring that cloud database or target up to date, it will continue doing that and continue doing that in real time. You can also build monitoring and alerting over the top of this. You can monitor that process. You can look for unusual volumes, unusual access to tables, unusual volumes on different tables. And it's not limited to a single target. You can use this change data, capture data for a variety of different target purposes. And IoT and edge processing is also something that is becoming more and more important across more and more industries. And the crucial thing here is that to think of your data architecture as a smart, flexible architecture. And it's not just for IoT data. This could also be anything that's high volume, like security data, for example, where you're maybe doing packet capture, or net flow data from routers, where that's high volume data, and you need to be able to collect that data in high volume from a lot of different places and do some processing and analytics at the edge. Maybe you're turning that raw data into information, reducing the volume of it, but keeping all of the information content. So maybe you're looking for changes and only moving changes across rather than every single data point. But you do that processing and analytics at the edge, and in some cases you need to feed back and react very quickly based on data being generated at the edge. That can then be moved into an on-premise and/or cloud server and build applications that span all of this. So the crucial thing is to be able to say, I'm building an application and I need it to be able to not just scale, but to have the processing and analytics in the right place. And that could be at the edge, it could be on-premise, it could be in the cloud, but it really shouldn't matter. It's a way of thinking about your topology is flexible, and where you do the processing and analytics should also be flexible, so it makes sense for that particular application. AI is also another important concept to consider, and it plays a huge role in a lot of different use cases. Operationalizing it means a number of different things. It means, firstly, you have to be able to collect and prepare and process data and continually write that. In the case that you've trained the model, it needs retraining. The model's not up to date anymore. So you need to continually write the training data ready for when you need to either first train the model or retrain the model on a periodic basis. But then once you have a model and the model's working and it's fitted to your data, operationalizing that involves doing real-time scoring, real-time predictions, real-time anomaly detection. And that means that you need to move your model and have your model running in a streaming fashion. You're passing this real-time data through it, and you're now able to make real-time predictions based on your model. And so that's really what operationalizing it means. It means being able to continually feed it data for training purposes, not running the training continuously, but running the training periodically when you're seeing that your model needs to be retrained. But then also being able to do real-time scoring to make real-time predictions and anomaly detection and everything else that machine learning is great at. So think about what are the overall best practices for streaming integration analytics. Now, firstly, you can't get there unless you move to a streaming first architecture where at least your data collection needs to be in real time and needs to be streaming data sources. You look at an open core model that utilizes and integrates with open source technologies, but then also supports mission critical enterprise environments, so it has all of the enterprise grade features that you need. And next generation platforms that instead of working on disk-based stored data are doing a lot of the processing and analytics in memory in real time, because memory is getting cheaper, processors are getting cheaper. But this shouldn't be complex technology. It should be something that is easy to work with and enables you to get to results quickly. And so a complete platform that integrates everything that you need so you can start working out of the box rather than having to build things out of bits and pieces, out of multiple products, trying to weave those together, trying to get as much as you can from a single kind of in-memory platform as possible. And that can also easily plug into your existing architecture for kind of a very fast time to ROI and a fast time to value, and producing business-friendly solutions that can be adopted broadly, and being able to do analytics that don't require developers, that require people that can work with data, that understand the data, and maybe they work with SQL. So they can build solutions and build, as they're closer to the business, they can build business-friendly solutions that can be adopted quickly. So a little bit about the Stream platform. We're a complete end-to-end platform that supports streaming integration and analytics across the enterprise cloud and IoT. We have a flexible architecture that allows you to deploy pieces of a data flow on-premise, at the edge, in the cloud, wherever it makes sense, and do all the pieces that you need in order to build these streaming integration analytics applications. And that could be everything from streaming data collection, so a streaming first architecture where you are collecting data from databases through change data capture. You're reading at the end of files as they're being written to stream those out, whether they're on disks or HDFS or wherever they may be. Being able to deal with message queues and sensors and all of the IoT protocols to stream data, to get your data into a streaming fashion. Then to be able to do in-memory stream processing using SQL-based continuous queries, to do real-time filtering, transformation, aggregation, and enrichment of streaming data, to get the best value out of your data as it's flowing through in memory without it ever needing to hit disk. Being able to do in-memory analytics where you are correlating data across one or more data stream, or you're correlating real-time streaming data with historical data that you may have been in a database or in Hadoop, and you're loading that into memory and you're correlating that. To be able to look for patterns or sequences of events over time that indicate something interesting is happening. So that's integrating complex event processing, or CEP. And do statistical analysis and anomaly detection, and to integrate machine learning, to trigger alerts and build visualizations. We have a full dashboard builder in the product for building visualizations. And finally, to be able to deliver the results of the data collection, processing, analytics to wherever you need, whether it's on enterprise or in the cloud, databases, files, Hadoop, storage, Kafka. And the key here is to integrate with the choices that you have made already. So we have lots and lots of sources and targets that we support, enable us to integrate with your enterprise software, from databases to your big data solution to Kafka, etc. And doing all of this in an enterprise-grade fashion that is inherently clustered, distributed, scalable, reliable, and secure. We saw in the demo, this is what the data flows look like. You can see that all of the processing is through data flows and through SQL-based queries that run in those flows. And this is how you build the dashboards through the dashboard builder that we also saw in the demo. There's 4 things to remember about the Stream platform. It's that it is an end-to-end platform that has everything you need to collect, process, analyze, deliver, and visualize streaming data. It's easy to use, enables you to build applications really quickly. It has a SQL-like language, so you don't have to learn to code to work with data. And so business analysts, data scientists can work with it. it integrates with the technology choices you've made. So we have integration for all the major enterprise databases, Kafka and other messaging technologies, the top 3 cloud platforms, the top 3 big data platforms, etc. And we are enterprise grade that has a full end-to-end security policy, encryption, authentication, authorization for accessing any of the components, any of the pieces of our platform. It's highly performant, highly scalable distributed architecture, and has reliability built into it with exactly one's processing guarantees available. So that's the presentation, and now I think, Catherine, we can open it up to questions.
Thanks so much, Steve. I'd like to remind everyone to submit your questions via the Q&A panel on the right-hand side of your screen. While we're waiting, I'll mention that we will be sending a follow-up email with a link to the recording of this webinar within the next few days. Please feel free to share this link with your colleagues. Now let's turn to our questions. Our first question is, can we do this just using open source or Kafka?
Well, the short answer is no. You could potentially try and build something like this using open source, right? You would need definitely more than just Kafka. Kafka is a piece. We integrate with Kafka on the source and targets. We also ship with Kafka as part of our product. You can switch our data streams to be Kafka streams very easily just by a flick of a toggle in the UI. But Kafka is just a small part of the puzzle. So if you're wanting to think about building this from open source, you would need multiple other components like an in-memory data grid, distributed processing, result storage, visualization, all of the data collectors, all of the data delivery, change data capture from databases, lots and lots of different components that you would have to identify open source for each one, evaluate and test that it works, integrate it together, build glue code. You're talking, a lot of work to even start to be able to think about building applications. So we obviously utilize open source, and we've incorporated a lot of open source into our platform, but we also have a lot of proprietary functionality that glues it all together, that enables it to be a scalable, reliable platform with exactly one's processing from end to end, that enables you to run high-performance continuous queries using our patented technology to be able to distribute continuous queries across different nodes on a network. And also with open source, you very rarely, if ever, get any UI capabilities, any way of building data flows visually, building dashboards visually. So it doesn't have the same ease of use. You have to rely on developers to build your data applications rather than the people that know data.
Thanks, Steve. I think we have time for just one more. What areas do you see AI and machine learning helping on?
It can help in so many different use cases. I think we're just seeing the tip of the iceberg now in the uses of AI in all industries, but especially the finance industry. I mean, AI and machine learning has been used. Finance industry is generally kind of cutting edge when it comes to the use of technologies, especially in the trading areas, but in areas of risk management and kind of understanding customers, understanding customer behavior, determining when to make loans, when to issue insurance policies, how to calculate premiums of insurance policies, identify complex risks that involve many, many different variables, to analyze security and your own employees' behavior, customer behavior, website visitor behavior, app user behavior, and to look for things that are unusual traffic. And the finance industry holds so much of our personal information, and recent events have shown that that can be catastrophic if it is released. So being able to spot what is usual within an organization and then react quickly if you see something unusual. If you are monitoring network traffic and 143 million records disappear outside the company, you would hope that you'd be able to spot that as unusual and spot it way before 143 million records disappeared. You'd hope to be able to spot it at the few thousand records to really head things off before they become massive issues that can be reputation damaging. So the short answer is, almost everywhere, with a lot of detailed examples, and we can go into those in more detail with you in person.
Thanks, Steve. Great. I regret that we're out of time. If we did not get to your specific question, we will follow up with you directly within the next few hours. On behalf of Steve Wilkes and the Stream team, I would like to thank you again for joining the session. Have a great rest of your day.